Alright, this is our first lecture on section 6.2, and we're using substitution to solve systems in this section. We're going to learn to, relearn and review how to solve a variable, or an equation or a formula for a single variable. And then we're going to use substitution to solve systems, and we're going to figure out what inconsistent and independent systems look like when solved by substitution, and what consistent dependent systems look like when solved by substitution. So back in section 4.6 of Lehman's book, we learned to solve a formula for one variable. So we want to just practice that again with our example number 7 here. So example number 7, it says form an expression for x in terms of y by solving the following equation for x. So I'm going to solve for the x variable here. This is the one that I'm interested in. So I'm going to put that in blue, and then I'm going to solve for that. So I'm going to get the 6y away from the x that I'm interested in by adding the opposite to both sides. And that's going to give me 2 plus, not plus anything, equals 8 minus 6y. And then finally, I'm going to go and I'm going to solve for that final for the x by removing the numeric coefficient. So I'm going to divide both sides by 2, which means I'm going to divide every single term by 2. And now I'm going to have that x is equal to, and we have 8 divided by 2, which is 4, and then minus 6 divided by 2, which is 3y. Now this over here on the right side is an expression in terms of y for the variable x. So we could substitute in for x this expression here. And that's exactly what we're going to be doing in this method of solving by substitution. So let's go over the steps. The first step that we're going to encounter in solving using substitution is we are going to do exactly what we did here. We're going to solve an equation for a single variable. And once we solve for that single variable, then we're going to evaluate the second equation at that expression. And then we plug in, and then we're going to solve that for the remaining variable. And we're going to plug into the one of the original equations with the solution for the variable. And then we're going to write the answer as an ordered pair. So let's just go ahead and practice this with example number 2. So example number 10. Example number 10 here, we already have one equation which is in terms of the other equation, or of the other variable. So x, you see, is equal to 3y is already solved for x in terms of y. So for this equation, x plus y equals 20, I'm going to use that second equation to substitute in for it. So this is my expression for x, and I'm going to substitute it in for x right here. So I'm going to do that by saying 3y plus y is equal to 20. And then I'm going to solve this equation. So this new equation I'm now solving. So you see step 1 here was already done for us, and then step 2 was to evaluate the second equation, and we're going to solve for the other equation, or solve for the other variable. So this is step 2b here. So we're just going to say 4y is equal to 20, and then multiply by the reciprocal here and here. And now finally, we know what y is equal to, and y is equal to 5. So now, once we have that, we're going to plug into an original equation. This is going to be our step 3, into an original equation and solve for x. So I'm going to use that x is equal to, and 3 times our y, which is 5, and that gives us that x is equal to 15. And then last but not least, we're going to write our answer as an ordered pair. Our x is equal to 15, and our y is equal to 5. And that's the solution. Now remember that the solution must satisfy both equations, so you can check, right? If x is equal to 15, does that equal to 3 times 5? Absolutely. If x is 15 plus y, which is 5, does that equal 20? Absolutely. And so we see that that's a solution.